in this prototype, what we want to do is write a prototype for the game of Connect 4. We're going to evaluate the core winning conditions given a point-in-time snapshot of a 7x6 board with 2 players, X and O. And largely, doesn't seem too different than the game of tic-tac-toe. Here is my input, and just to prove to you that I know with high certainty that I can convert this input into the expected output, I'm actually just going to do this for you. So in both cases, I can hack something together, and what I want to share with you is another idea. What you're looking for in a prototyping process is fundamental structural problems. Lateral problems, namely cases where you can either replace your way through to fixing it, or you can make surgical, single function, single line changes, are really not a big deal. It's what we often call fit and finish. So I'm going to write probably just about the worst code I can in order to parse this, just to show you that it doesn't really matter, because I can prove that I can do it. And if you don't like my code, well, look, if you have the time to rewrite it, you can rewrite it. But your rewrite won't cause downstream changes to the rest of what I want to write. And I really want to make sure that I don't have to churn through this code, rewriting lots of pieces from scratch. I'm looking for structural problems, not laterally, oh, change this one line over here to this other formulation. And so here, it's something like for_line and state.strip.splitlines. And you'll see some of the operative practice that we use here, namely working very incrementally. So there we go, line.strip. Let's strip that out. There we go. I don't want the lines that start with a comment. So here we go here. We'll skip that as well. Those are the remaining lines. I'm going to split this on single white space. There we go. And then from this, I'm going to put it into my NumPy and D array. So from NumPy, we'll pull in our array. Here, I'll actually do an empty structure. Actually, no, I'm going to do it like this. I'm going to do a full structure. So here's my board state, which is a full structure of D type U1. And here, notice I'm not even going to do anything with it yet. I'm going to just print it to the screen just as I go. By the way, this needs a fill value. And I guess I need to know the size of this. So this is what, 7x6? And we better get our typing going there. And here we go. And by the way, this should be our board or our result. So here we go. OK, so that looks good. And then here, if I'm going to go on this line by line, this is the row number. And this is where it gets a little bit tricky. So no, we'll start there. Because we're skipping this row, this really shouldn't be counted in the row number. So that's going to be incorrect. So we actually need to fold that into our parsing here. But you know what? This is just a very simple, take some code and package it up, right? This is really just, something like this. Let's take this and, for each line in this structure, do this. And then, even if we want to use the non-iteration helper stupid way to do this, we can do this like this. OK, so I think that gives us that. And here we can even make this kind of look like our enumerate. So here, this is our, skip comments, or probably parse is a better name for this. So there we go. And here, we're moving things around. There we go. And I guess we can say by default start at 0. There we go. There we have that. That's our row number. And yep, beautiful. And then let's get our column number. So for each one of these, we just enumerate this. So this is our cell. So here we have our return value for our row number and our cell number, or our column number rather, and that equals whatever the cell value is. And here I could be a little bit careful about whether I want to actually use this dot or if I want to use like an empty string here. So let's actually make this a null byte if it's missing. And here, let's say if the cell value is one of our symbols. So let's see what that cell value would be. That would be a string. So if the cell value in our symbols. And our symbols, before we put them into a list, actually we should have put them into a set because we know that they're unique and we know that they're guaranteed to be distinct. Otherwise, that really ruins our weekend. So there we go. And here we go. That's our row number. That's our column number. Let's check to make sure that we didn't do something wrong here. We said this was 7 by 6, so it's actually 6 high and 7 wide. So we swapped these axes. There we go. And this is not good code, right? It's not. It doesn't, oh, by the way, this shouldn't be an R string. This should be like that. There we go. Not good code, but it works. And, if you want to replace it, you can replace it largely just by swapping out this, full parse function. So here we'll say this is preprocess. Doesn't even matter what I call it because this is so isolated to this one block of code. If I give it a terrible name, really the consequences of this terrible name are quite minimal. But here we go. So I can say state. So there we go. And of course we have to always return something. So it's really just not that difficult for us to perform these parsing tasks. We've done them enough times. We know we can do them. We know we can do them at poor quality. But again, the purpose of prototyping is not to assess whether or not you can do something at better or worse quality. The purpose of prototyping is to assess whether it can be done and whether it can be done at sufficient quality. And this is done at sufficient quality, at sufficient speed. And if you want to improve this parsing code, there's a bunch of ways you can do it. Have at it. From my perspective, all that looks like is, you swap out those lines. It doesn't really matter on the overall structure of the problem that's being solved. Now, you can see the choice of the, I'll show you one thing we also do. I really like fixing in place certain aspects. And to keep my iteration loop tight, one of the things that I'm going to be really careful to do is I'm going to avoid the end-to-end until I'm happy with the idea of, okay, now I'm ready to check everything holistically. So one thing I will do is I'll use things like the pickle module, even though I shouldn't really use it for anything real, in order to manage to snapshot certain states of the problem. So what I'm going to do is I'm going to dump my NumPy and D array to a pickle object, and I'm going to pick it up in the next cell, just so that I have fixed in place what the input looks like, and I don't have to go through the input processing. I can just mess around with that. And I'll, if I want to change this a little bit, I might hard code it. Or another way that I might do this is, honestly, between you and me, cut and paste. If I really want to tweak this so I can check other possibilities, I really don't see where I need to be rerunning the processing code over and over and over in order to validate that the code that I'm working on right now, which is not the processing code, works. So I'm more than happy to either cut and paste this thing or pickle it and pick it up later, because largely if that processing did take some time, I don't need to spend 2 seconds doing something that I know already works. Set a checkpoint and pick up from there. So I'll use a cut and paste because I think I probably want to be able to kind of play with this a little bit, kind of tweak it in that fashion. So this is the approach that I'll take. Now, here, I think this is actually pretty similar to the case of a game of tic-tac-toe larger than 3 by 3, in which case I can use the sliding window view from Stride Tricks. So let's use that. And here we're looking for anything that's 4 by 4. So here we're going to take the state and look for anything that's a size 4 by 4. And so that gives us, there we go. And let's figure out why that doesn't give us, do we have to give this first? Okay. And let's figure out what our sliding window view requires of us. Fast iteration environments are very helpful because you can never remember all the details. So this is the data and then the axes of what you want to look at it. So it should be the state in 4 by 4. So that's good. So why doesn't this, let's see what our state is. And let's see what our shape is. Oh, and we have some typo here. Oh, because of the stupid commas and the, you know, what you doing to me, NumPy? You know, one other key thing to this rapid prototyping, get to know your editor very well, because you can do things really poorly and you can still kind of move on with your life. And really the core idea to all this prototyping is just moving on with your life. So here we can see that, and we have to use that chain trick that we did before just to get each individual block. There we go. So here we have each individual block of size 4 by 4, and then clearly the criteria that we're looking for is largely very similar to what we did previously. You know, we're going to take the state, and then we'll say, you know, for each row in range 4 will yield whether it was, this is the row number, by the way, we'll yield the block for that row number is equal to, you know, for the player, is equal to the player. And here, one thing that we might think about revisiting is whether or not the aggregation is worthwhile. Like, you can think typically what we might say is we might say that we got all of these, but that aggregation itself might not be what we want. It's often the case that the decisions that we have to make in order to ensure that this is structurally correct are about, are we preserving enough data in order to make changes later down the line? And one of the cases where we throw away data, where we might decrease the entropy of our circumstances, are anytime we do some sort of aggregation, because we're throwing away information. And so, and let's say X and O are our players. And so one question that might come up in this process of trying to figure out how do I model this correctly is, do I want this to be a true false whether you won in that particular criteria, or do I want this to just be what the state is for that particular criteria? Because what if somebody came to me and they said, oh, this is some sort of leapfrog version of Connect 4 where you're looking at windows of size 5 and you need a value, skip over the other player, a value. And in the previous version, that would add some complexity into my win condition. Whereas in this version, it wouldn't, because here I would just say, you know, the simple win condition is win.all, and that gives you, you know, the winning condition. So aggregations of some value is always kind of that key to this. Now, here, do I really need to prototype going through the columns? I know that it's mostly cut and paste, sometimes for just completeness purpose, just to, you know, ease my mind, or to burn through time, I will do these things. And so it's not always the case that I'll skip steps that I don't need to do. It's often the case that I'll do those steps just because they're really easy steps that I can do, and I can do them while thinking about something else at the same time, and eventually they have to be done. What I'm trying to do in the development process is I have these bottlenecks, and the bottlenecks that I have are not even knowing where to start with something. The bottlenecks are not even knowing if something is possible. The bottlenecks are there's many different choices for how I design something. Which is the choice that I pick? And the bottleneck is, well, I actually have to type all the code, and I can only type so fast. And what I want to do in my prototyping process is to rearrange those bottlenecks. So I can get out of the way these core fundamental questions. What does the design look like? How does the data get passed around? What assumptions am I making that are going to make it harder for me to extend this later? And what assumptions can I just make? And I also need to actually develop the code. And so oftentimes I'll do silly things like just, you know, fill in these criteria where I know that I have to do it anyway, but it doesn't really gain me anything more intellectually or about the problem itself to fill those in, just because while I'm thinking ahead, I can do something manual. And so here, I'm pretty happy that I've solved the problem itself. You know, I have the row numbers, the column numbers, the diagonals are largely just going to be, you know, NumPy, diagonal, and flip LR of the diagonal. And we can see we've actually solved now the full game. We just have to take these two pieces of the prototype and put them together. And I will preserve that end-to-end testing until I'm happy with the pieces individually. Because if something goes wrong, it's always the case you want to decompose that. Well, I will preserve these in this decomposed fashion until I'm happy that I can merge them together. But I think that does well for that particular prototype.